Here I have an exciting problem from the 2023 American Mathematics Competition's Qualifying Exam 12A. Now, this is problem number 12 of 25, which means it's about medium difficulty of the already difficult exam. And those of you who take pre-calculus or took pre-calculus of any kind would probably know how to solve this problem without too much trouble. And I'll show you in this video that it's not that bad. We're asked to find the value of 2 cubed minus 1 cubed plus 4 cubed minus 3 cubed, alternating these numbers on and on until 18 cubed minus 17 cubed. And so how might you go about solving this? And one of my favorite ways to go about solving problems like this is to rewrite them in terms of sigma notation, okay? And so there's many different ways you can write this in sigma notation. So for example, you can write it like this. You have this sum as n goes from 1 to 18, right, because we have 18 terms, of negative 1 to the n, because we're alternating and it's negative on the odd terms, of n cubed. But unfortunately, this kind of sigma notation doesn't really help us at all, because it's really difficult to work with the negative 1 to the n's. So instead, I'll introduce you to the better way to write this, and that's going to involve a little bit of rearrangement. So you can see that all of the terms that we're adding that are positive and not taking away are all of odd parity, all right, which just means that their parity just has to do with evenness or oddness. So they have all odd parity. They follow the 2k structure. And that's exactly why we're going to rewrite this as partly as this, 2 cubed plus 4 cubed plus 6 cubed, of course, all the way up to 18 cubed. And then we subtract minus 1 cubed, minus 3 cubed, minus 5 cubed. But since all the odd terms are subtracted, we can just factor out the negative 1 and subtract the sum of all those terms. So you have 1 cubed plus 3 cubed, on and on until 17 cubed. And now we can rewrite this in terms of a different form of sigma notation. So I'll show you right now. Because we know that these follow the 2k structure, we can rewrite this as the sum, right, as n goes from 1 to, well, what do we want to rewrite this as if we're going to have 2n quantity cubed, right? Well, we know the starting value is going to be 1, of course, because it's 2. The last is 18, so n should be 9. So we have sum from 1 to 9 of 2n quantity cubed is going to cover this entire even part, all right? And we subtract from that the sum of the odd part, okay, the sum of all the odds. And so what do we get here? We have the sum. Well, what's our first value? It's 1, and the last is 17. And we can write that as 2n plus 1, but I'm going to rewrite it as 2n minus 1 quantity cubed. All right, and I'm going to do that for a special reason, because that way the bounds of our sigma, n going from 1 to 9, are the same as here. So it's a nice and neater structure to work with. And so, of course, you can see that if you plug in 9 here, you have 18 minus 1, which becomes 17, which is our last number. And if you plug in 1 here, you have 2 minus 1, which is 1, which is our first number. So it works out nicely. And now what we're going to do is we're going to expand these cubes, okay? So what I'm going to do here is I'm going to rewrite this as s, right? And the reason I rewrite this as s is because you can see here we have a 2n inside of this sigma. So when we expand it out the cubic here, we're going to see that we can get some cancellation because of the negative. So what do I mean? Let's take a look. We have here the sum of n going from 1 to 9. And how do we expand this binomial? Well, there's a theorem called the binomial theorem. And that's going to state x plus y to the nth power, all right, is going to be equal to the sum of k going from 0 to n of n choose k, which is our combination, x to the n minus k, y to the k. In this case, of course, our y is negative 1, because it's the same thing as saying plus negative 1, all right? X is 2n, and n is 3 here in this case. All right, and so now we can use the binomial theorem. What do we get? For the first term, we have 2n quantity cubed, all right, which is going to be, of course, 8n cubed, like this. And then we add to that, well, 3 choose 1 is going to be 3 times 2n quantity squared times negative 1 to the first power. And we add to that 3 choose 2, which is equal to 3 choose 1 by the kind of mirror rule, I call it, where n choose k is equal to n choose n minus k. Okay? And so we have 3 times just 2n times negative 1 squared. All right? We're squaring this now. And then we finally add that to negative 1 cubed, which is our last term. There you go. Because again, in this case, k is going to be n, and so we have n minus n, which is 0 here, so this becomes 1, and then we have y cubed. All right, and now let's move on and simplify this further. So we get that it's equal to s minus, we get the sum here of n going from 1 to 9 of 8n cubed, plus, well, what's 2n quantity squared? That's 4n squared times 3 is 12n squared. and then negative 1 to the first power is in minus. So you have minus 12n squared here, like this. And here, negative 1 squared is just 1, and we have plus 3 times 2n, which is 6n. So we have plus 6n, of course. And then finally, negative 1 cubed is negative 1, so we just say minus 1. All right. And now what we're going to do is we're going to do something that I like to call splitting the sigma, where the sum of this altogether is the same thing as the sum of the individual parts. A summation is a linear operator, okay? And I'll card a video that on operators and what they mean in the card section. You'll see that pop up right now. But that just means that the sum of the sums, in a funny way, is equal to the sums of the sums. So it's just sum of A plus sum of B. So again, that's kind of a weird thing to say, but it's the way we're going to split the sigma, all right? And so we ultimately get that this is equal to S minus, all right? And now we're going to start splitting the sigma for real. The sum from 1 to 9 of 8n cubed, all right? Subtract that from the sum, right, going from 1 to 9 of 12n squared, and we add that to the sum of n going from 1 to 9 of 6n, and finally we subtract from that the sum of n going from, that's a disgusting sum, hold on, let me rewrite that, not too easy with the mouse, from 1 to 9 of just 1. All right, now let's do some simplification again. Notice that the sum of 1 to 9 of 8n cubed is going to be the same thing as what we have up here, it's s. And this is where the cancellation comes in, because we don't want to have to use the sum of cubes formula for that. All right, now the sum of 1 to 9 of just 1 is the same thing as adding 1 to itself 9 times, which, guess what, is just 9. So there you go. And now you can use the idea of the linearity of this summation operator to hop the 6 out on front. So you have 6 over here. We can take it out. And then we have 12n squared, which we can again hop out in the front. Again, that's just basically the idea of factoring it out of all the terms. All right. And now what we're going to do is we're going to basically just split this out even more. So now we're going to distribute this negative 1 over here. So we get s minus s plus 12 times the sum of n going from 1 to 9 of n squared. And we add that, or sorry, not add, but subtract that now, remember, distributing this negative 1 sign over here. We get minus the 6 times the sum going from 1 to 9 of n. And then we just add back the sum of 1 to 9 of 1, which is just 9, we said. Okay, and now we can see the s's cancel out, which is very nice. And what we have now is the sum of squares and a sum of just the regular units. And what does that mean? Well, let me remember and let you remind yourself of the sum of squares formula and the regular sum formula. So the sum, as I goes from 1 to k of I, is equal to k times k plus 1 halves. And there's a couple of cool proofs on how to do this. And let me know, of course, in the comments if you want to see a Josh Academy video on the sum of I going from 1 to k. And then the sum of squares, and again, let me know if you want a video on that, I going from 1 to k of I squared is going to equal k by k plus 1 by 2k plus 1. And we divide all of that by 6. Like that. All right? Now, let's apply that formula. So ultimately here we get 12 times, well here k is 9, and so we get times 9 times 9 plus 1 is 10, times 2 times 9 plus 1 is going to be 19, and we take that all over 6. Then we subtract from that 6 times, again, n is going to be 9, times 9 plus 1 is 10, so we have 9 times 10 halves, and we add back 9. Now, of course, you can cancel out the 12 and the 6, leaving a 2 up here. You can cancel out the 2 and 6 here, leaving a 3 times this. And so we ultimately get 2 by 9 by 10 by 19, which is going to be, well, 2 times 9 is 18, times 10 is 180, times 19. So you have 180 times 19. And we subtract from that, well, 3 times 9 times 10 is going to be 3 times 9 is 27, times 10 is 270, plus 9. And what's negative 270 plus 9? Well, it's 261. So you have 261. Now, what is 180 times 19? A little mental math trick is that it's the same thing as 180 times 20 minus 180. So you have 180 by 20, all right, which is easier to compute than 180 by 19, minus 180 minus 261. All right, and this basically is going to be 180 by 20 is going to be 360 times 10 is going to be 3600. And then subtract from that, well, 180 minus 261 is going to be the same thing as subtracting 441. And so we're left with the answer should be 3,159. So if we add this back, we should get 3,600. So let's see if 3159 is an answer that we had in the beginning. And lo and behold, it is. So the answer to the question is D, 3159. So I hope that this video helps you figure out this problem, and I actually encourage you to pause this video in the beginning and see if you could solve this on your own. But it just shows the importance of using notation, like sigma notation, to help you work with this stuff easier. Again, this is not the only way to do this problem, so I encourage you to find other ways of solving this problem without just using sigma notation. Perhaps you've only done Algebra 2 and Trigonometry classes, and you don't exactly know how to do sigma notation yet. It's still doable to solve this problem without it. Till next time.